Let me make sure I know. Make sure I'm telling you right. Yeah, there's just some questions. So that's part of the practice. But I just want to jump straight over so we can knock this out and you guys can just finish up your work. So like I said, now we're doing surface currents, CN, which stands for Cornell notes. These are a little bit different. We'll talk about them. Let me go ahead and share that screen so we can talk about how these work versus the guided notes. All right, so if we see here, oops, we click on the surface currents. So Cornell notes work a little bit differently. It's just a different note strategy. What they have is they have kind of key questions out to the left side. And then as we go through the notes, you're going to be answering them out to the right. It does go pretty much in order. But one key difference here is you've got to kind of summarize the topic or summarize the idea. So this just works a little bit on a different skill in terms of note taking. So take a look at the questions. And then as we go through the notes, that's what you're going to be kind of putting that meat and potatoes information into the notes section. Okay, are there any questions about that? No, I'm assuming that's a no. So let's go ahead and let's talk about ocean currents. Okay, ocean currents. So ocean currents is the mass movement or flow of ocean water. Think of it as a river of flowing water within the ocean. And there are actually two types of ocean currents. There's surface currents and there are deep sea currents, and they're driven by different factors. That's the key. They're both the mass movement or flow of water, but the surface currents are affected by one thing, and the deep sea currents are driven by a different factor. If I go too fast on this one, please pop in and just say, hey, can you head back to that slide? I know it's a little bit different with this strategy, and normally I would see when you guys are done writing, but I can't really see that right now. So just if I go too fast, stop me and I'll go back, okay?
So is that what we put at the top of the notes for what are ocean currents?
Yep, I would put mass movement of ocean water or a river within the ocean, and then there's surface and deep sea. Yep, just kind of summarize that. Okay, am I good to move on? All right, move on. Okay. Just hop in if you guys, like I said, if you guys get stuck, just hop in and let me know. Go ahead and skip number 2 and 3 for now and jump down to number 4. Okay. Ocean currents form closed loops, which are called gyres. All right, a gyre is a large system of connecting and rotating ocean currents. And gyres are caused by the Coriolis effect and wind currents that result from the friction of the friction caused by the rotation of the Earth. Okay, there are 5 major ocean-wide gyres: the North Atlantic Gyre, the South Atlantic Gyre. Sorry, I should be pointing these out with my little laser pointer thing. We have the North Atlantic Gyre. We have the South. Oh no, I lied. North Atlantic Gyre over here. South Atlantic Gyre over here. We've got the North Pacific Gyre right here, the South Pacific Gyre right here, and then we have the Indian Ocean Gyre down here. So these are the 5 main giant circulation patterns within the ocean. So number 4, gyre is a large system of rotating ocean currents. Now I'm going to help you with number 2 and number 3, or I'm going to help you with number 3. It says describe how the Coriolis effect influences the ocean surface currents. So this is what it causes them to do. It causes them to be deflected or form gyres. You can put it, they form gyres, causes them to form gyres.
Was that for number 5?
So for number 3, describe how the Coriolis effect influences
Oh,
surface
3.
currents. It causes them to form gyres. And then you can answer number 4, what is a gyre? The notes here are just a little bit out of order, unfortunately. I think I opened the wrong version. I have like 25 versions of this because I've been teaching this for so long. So we'll just hop around and I'll help you guys out. Okay, so now we're going to jump back up to the surface currents. Surface currents are controlled by 3 main factors: global winds, the Coriolis effect, and continental deflection. So this will help you answer, I believe it is number 2. Yeah, explain how surface currents develop. So the first part of how they develop, they're developed by either global winds, Coriolis effect, or continental deflections. Okay. So what we need to understand is the Coriolis effect is the reason that things appear to move in curved paths because the Earth is spinning. What we need to understand is they're moving just generally north or south, but because the Earth is turning, it looks like a giant curve, okay? So what this causes to happen is in the Northern Hemisphere, currents move in a clockwise direction, okay, clockwise direction. I'm gonna go back to that map in just a second so we can see some of these in action. In the Southern Hemisphere, the winds cause things to move in a counterclockwise direction. So if we look back at this map, here we are in the Northern Hemisphere and look at the arrows. If you can see it kind of closely, it goes in a clockwise direction. But then if you look in the Southern Hemisphere, it's going the opposite direction. It's actually counterclockwise. So if we look at the Pacific one, this Northern Hemisphere goes clockwise, just like this. And then the Southern Hemisphere one goes counterclockwise. And that's true for all the ones in the Southern Hemisphere, and all the ones in the Northern Hemisphere go clockwise. Oh, there's another map here as well. Okay, so again, here's the North Pacific, clockwise, South Pacific, counterclockwise. Okay. So a surface current is the horizontal stream-like movement of water that occurs at or near the ocean's surface. This can reach depths of several hundred meters because that's still considered the top of the ocean. And this is largely responsible for the climate in many parts of the world. So for the second part of number 2, where it says, why are surface currents important? They're important because they affect the climate, largely responsible for the climate in parts of the world. So everyone at this point should have 1, 2, 3, and 4 answered, and we should be waiting for number 5. Is that correct? Everyone's good on 1, 2, 3, and 4?
I'm good.
Yeah, I just need to know the last bit of that. It says they're important because they are largely responsible for
Climate.
the
Yeah.
climate. Yeah.
Mhm.
Okay, I'm good then.
Sydney, you're good? I'll just assume that's a yes. Okay. Now, warm water surface currents are what kind of affect the eastern United States the most. So we're going to be talking a lot about the Gulf Stream. Let me see if I've got a picture. Yeah, here's the Gulf Stream. Okay. And so what happens is the Gulf of Mexico is down here at the bottom left. The current comes out of the Gulf of Mexico and it goes up the eastern coast of the United States and travels all the way out into the North Atlantic. So how does this affect the climate? Well, it brings all this warm water with it. So it makes the climate more warm and humid than we would expect it to be. If you've ever been in Florida or Georgia or South Carolina, or even parts of North Carolina for that matter, you know it's usually pretty warm and pretty humid. And that's because it's so close to this warm ocean current coming up the Gulf Stream, okay? As you can see, as it travels more north, it experiences more cold water, so it does eventually lose its temperature. This yellow and green is kind of a medium temperature, and then in blue is the colder temperatures. But the Gulf Stream comes out of the Gulf of Mexico, up the eastern coast of the United States, and it brings warm, humid weather. It makes the climate more warm and humid than we would expect it to be. So if you guys want to go to number 6, that'll answer number 6. It also answers number 5. How are surface ocean currents identified? They're identified from where they come from. That's why we call it the Gulf Stream. It's coming out of the Gulf of Mexico. All right, so for number 5, ocean currents are named for where they come from. And then you can start answering number 6 because we can see it brings warm, humid weather because of that warm water to the eastern coast of the United States. Okay. Thank you for typing in the chat, Sydney. I guess that also answers number 7. I apologize. So you should have 5, 6, and 7 answered now. So 5, how are they identified? Identified based off of where they come from. Number 6, the location of the Gulf Stream. So out of the Gulf of Mexico up the east coast. And number 7, how does it influence climate? Brings warm, humid weather to the east coast.
So I'm lost. I got lost.
That's okay. Which number?
6 and 7.
Okay, so for 6, it's asking where it comes from, right? Or where it's located. So
Yep.
it comes from the Gulf of Mexico up the east coast.
To the East Coast?
Up the east coast.
Up the East Coast. Okay, sorry.
No, you're okay.
Okay, and 7?
So it makes it more warm and humid than it should be.
Okay, so, okay, got it.
All right, let me jump to where we need to be. Now, upwelling, the next question is going to talk about part of the occurrence of a deep sea current. So we'll get to upwelling, just understand that we're kind of giving you more of the story than are on the notes, okay? So those were surface currents. Deep sea currents are a little bit different, okay? They're the stream-like movement of ocean water far below the surface, and these are driven by the changes in density. So as water goes to the poles, the temperature is going to decrease, which is going to make the density higher. So it's going to sink to the bottom. And then as it gets to the equator, it warms up, and that's going to cause it to rise. It can also occur because of changes in salinity. Again, increasing the salinity increases the density. So this can also drive the deep sea currents. So what we can see here is in this diagram, the surface currents are occurring in the top couple hundred meters of the water. When I'm talking about deep sea currents, I'm talking about the bottom of the ocean, okay? Bottom of the ocean. Good, my battery's running low. Hopefully it will not die. So here we go, upwelling. So what is upwelling? Well, upwelling is the movement of deep, cold, nutrient-rich water to the surface. Okay, now why are upwellings important? It all has to do with those nutrients. when the water comes up from the deep parts of the ocean, it brings very nutrient-rich water with it. The nutrients at the top of the ocean tend to get used up by the life that lives there, or it just is farther away from the sources that are giving the water those nutrients. But what's really important is during the upwelling event, in those areas where upwelling occurs, rather, you can have large aquatic communities because there's such a vast amount of nutrients in the water. So they become very, very good fishing grounds. So, you know, all our seafood and stuff like that is usually, we hunt for those fish in areas of upwelling, excuse me. So upwelling is the vertical movement of deep, cold, nutrient-rich water to the surface. So that should answer number 8 and number 9. I'm going to pause it just for a second so I can see how much battery I have. Oh, that's pretty low. Okay, if my computer dies and the class crashes, I will just open it up on my other computer. So just give me a second if it does crash. But I'm going to go ahead and I'm going to try and move through this while I still have battery. All right, back to the PowerPoint. All right, share the screen. Okay, so here we can see an upwelling event. So you guys see as the currents kind of hit the continent, or if the density is changing, what happens is that deep water from deep in the ground gets pushed upward. That's that vertical movement right here, right? So the current's coming in and it gets pushed upward, and that brings lots of nutrient-rich water to the top. That's what deep upwelling looks like. All right, no, we don't need to do all this, come on. Okay, yeah, this was definitely the wrong PowerPoint, but that's okay. I had most of the same information. So let me go through the last questions with you while we still have battery. So number 10, how does density affect currents? As water becomes more dense, it sinks. As it becomes less dense, it rises, and that drives the density current. So just go ahead, you can put in, it drives the density currents. Changes in density drive the density currents. All right, number 11 asks, what is the main difference between a surface current, density current, and upwelling? Well, there's two main things. It has to do with the direction of movement and the cause of movement. So direction of movement and the cause of movement. Because surface and density currents are both horizontal movement, where upwelling is vertical movement. Surface currents are driven by wind, while upwelling and density currents are driven by changes in that density. So those are the two main things. So the main differences between surface current and density current has to do with the type of movement, vertical or horizontal, and the driving force, whether it's wind or density.
So the answer is the direction of movement and the cause of movement.
Yes.
Okay.
And then for number 12, we have described the global conveyor belt. So basically what this is if you take all the surface currents and all the deep sea currents together, they all eventually connect. So there's no part of the ocean that's really separate from the rest of the ocean. So the global conveyor belt is the connection between surface currents and deep sea currents that circulates water through the whole ocean. So connection between surface and deep sea currents, and it mixes the whole ocean. Now that last map was normally because we would eventually go through and label an actual map of the ocean, but it doesn't even look like it showed up, so that's awesome. And we're not going to be able to do that on the computer, so just skip that last page. Okay. So all that you guys really do have left You have the practice, or you get the summary at the end of the composition notes, and then you have the practice. I guess I shouldn't stop sharing. I could keep sharing and show you where I'm talking about. But then you have that vocab. So the article is the first, is this one right here. This is the article. I've even highlighted the words for you. How nice. So you're just going to read this about the ocean water. And then the vocab is what you're going to fill out using that article. Okay. So I've given you the word, I've given you a sentence, I've given you pictures to help you. Don't worry about predict meaning versus meaning. We would normally, predict in class and then find out what the meaning is. Just go ahead and give me actual meanings based off of what the article says. Okay. But I want to open it up to questions so you guys can ask them so this doesn't die on me. What questions do you guys have?
I'm good.
Okay. So finish up the review at the end of those notes, do the reading, fill in the vocab, and then the X ticket is the last thing you have to submit. Okay. Monday, I just give you a heads up, Monday, we will continue talking about oceans. We're going to talk about waves and tides, and that will finish up our new information on oceans. Tuesday, we will review for the final, and then when you guys come in on Wednesday, you'll be taking the final. Okay?
Okay.
All right.
All right, guys, thank you for zooming in today, and I will see if you're coming in for tutoring tomorrow is from 10 to 12. If not, I will see you on Monday. All right, guys, have a good one.